time of descent of a projectile thrown from ground. So this is the horizontal direction, and a body of mass m, that means a projectile of mass m, will describe this type of parabolic trajectory, and the projectile will strike the ground. At this point, this is the vertically downward direction. The projectile, the velocity of projectile will be resolved into two rectangular components in these two mutually perpendicular direction. U is the initial velocity of the projectile, which is thrown at an angle theta with the ground. This horizontal O be the initial point from which the projectile of mass m is thrown with an initial velocity u, and ux is the horizontal component, which is equal to u cos theta. Ux equal u cos theta is the horizontal component of initial velocity u of the projectile at the initial point O. Now we can denote the vertical direction. This is the vertical direction, and the vertical component of the initial velocity u is uy, which is u sin theta. So you can denote uy in a proper way. So uy equal vertical component of initial velocity is uy. Uy equal u sin theta. U is resolved into two components, ux and uy. And ux is the horizontal component of initial velocity u, and uy is the vertical component, and it is the y-axis. Now we can denote the maximum height, h max. This is the maximum height attained by the projectile at the point A. The projectile is at the point A. When the projectile is at the point A, and we can draw a normal AN on the horizontal direction, then we get the maximum height at that point A. And at the point A, at the highest point A, the projectile will have the tangential velocity v parallel to the horizontal direction, and this is the vertical direction at the highest point A. Now B is the point at which the projectile strikes the ground with instantaneous velocity v prime. Now we can resolve this this final velocity v prime in two mutually perpendicular direction. So v y prime is a vertical component of final velocity v prime, and v prime x is the horizontal component of final velocity v prime at the point B. This angle will be alpha. This angle is alpha, with which the projectile strikes the ground with the horizontal direction. Now let u be the velocity with which projectile be thrown at an angle theta with the ground from the point O on the ground. When the projectile of mass m is at the highest point, when the projectile of mass m is at the highest point A, highest point A, comma, it will have the velocity. It will have the velocity v. It will have the velocity v along the tangent ax prime. Along the tangent ax prime parallel to the horizontal direction. along the tangent ax prime. Now we can denote the tangent at the highest point A. This is ax prime is the tangent along which the velocity v will be acting. It will have the velocity v along the tangent ax prime. The vertical component of the final velocity v at the highest point A at the point A is Vy equal V cos 90 degree, because Vy is perpendicular to V or perpendicular to the tangent Ay. So therefore Vy equal to 0 because cos 90 degree is 0. So we get the vertical component of final velocity of the projectile at the highest point A. Vy acts vertically in a vertically upward direction. So vertical component of the final velocity will be 0. Now the horizontal component of velocity. Now the horizontal component of velocity of the projectile, horizontal component of velocity of the projectile remains constant during the time of flight of the projectile. Hence, the horizontal component of the final velocity at the highest point A will be horizontal component of the velocity v at the highest point, the horizontal component of velocity v of the projectile at the highest point A is Vx equal V cos 0 degree. Vx equal V cos 0 degree because Vx is parallel to V. Therefore, we get Vx equal V. Again, also, horizontal component of velocity remains constant. That's why Vx equal Ux equal U cos theta. Therefore, horizontal component of final velocity at the highest point is Vx equal V equal Ux equal U cos theta. Using the equation S equal ut plus half at square between the 2 points A and B in vertically downward direction. Using the equation S equal ut plus half at square, S equal ut plus half, not 80 only, 80 square between the 2 points A and B, we get in vertically downward direction. Using the equation S equal ut plus half 80 square, here it is written 80 only, but half 80 square between the 2 points A and B in vertically downward direction, we get in vertically downward direction, we get H max equal minus Vy T1 minus Vy T2 plus half under bracket plus G T2 square, where acceleration due to gravity in vertically downward direction is plus G, where T2 is the time of descent. Time of descent. Time of descent. In this case, T2 is the time of descent in which it travels from the highest point A to the ground, that is up to the point B. It travels from A to B and strikes the ground at the point B. Strikes the ground at the point B. And in this case, Vy, vertical component of velocity Vy, is in the opposite direction with respect to the vertically downward direction. That's why in place of u, we have used minus Vy. And here h max is the maximum height attained by the projectile, which has the expression u square sine square theta divided by 2g, which is the maximum height attained by the projectile at the highest point A, which is the maximum height attained by the projectile, maximum height attained by the projectile at A. Now putting the expression of h max, we get h max equals 0 half h max equals 0 plus half g2 square, where Vy is 0, or comma now in the diagram, using s equal ut plus half at square, for the students, for my students, no need to denote this portion denoted by blue color. At the highest point, and using the equation s equal ut plus half at square between the 2 points A and B, the displacement s will be h max in vertically downward direction, and now initial velocity u will be minus Vy. So now in place of u, we have to write minus Vy, minus Vy. Vy acts vertically upward direction and u acts in vertically downward direction. That's why in place of u, we have to write minus Vy, because we are applying the equation s equal ut plus half at square in vertically downward direction. That's why u equal to minus Vy. And also Vy equal to 0. Hence, we get T2 or comma T2 equal root over 2 h max divided by g, root over 2 h max divided by g, small g, or comma T2 equal root over 2 by g dot h max, 2 by g dot h max under square root dot h max, or comma T2 equal, or comma T2 equal 2 by g, root over 2 by g. In place of h max we can write u square sine square theta divided by 2g, divided by 2g, or comma T2 equal u square sine square theta divided by g square, u square sine square theta divided by g square. Therefore, T2 equal u sine theta divided by g, u sine theta divided by g. not u square sin square theta, it should be u sin theta divided by g. So T2 should be u sin theta divided by g, whole divided by g. So this is the expression of T2, that is time of descent, in which the projectile travels from the highest point to the point B at which the projectile strikes the ground. T2 equal u sin theta divided by g, which is time of descent. Of the projectile, time of descent of the projectile, in which it reaches, not he, it should be it reaches to the ground, in which it reaches to the ground from the highest point, from the highest point. Time of descent of the projectile in which it reaches to the ground from the highest point. Also, the time of ascent in which the projectile travels from lowest point to the highest point, that is from O to A. Time of ascent of the projectile, time of ascent of the projectile is T1 equal u sin theta divided by g, u sin theta divided by g. But T2 is also u sin theta divided by g. Therefore, T1 equal T2. Hence, we can say that the time of ascent is equal to time of descent, is equal to the time of descent of the projectile. Therefore, the total time of flight, the total time of flight is T equal T1 plus T2. So this is the additional information. Therefore, T equal to T1 or T equal to T2. Therefore, 2 T equal to T1. 2T1 also T equal to T2. That means total time of flight is equal to twice the time of descent. Therefore, T is equal to u sin theta divided by g. So this is T equal to u sin theta divided by g, which is the total time of flight of the projectile thrown from ground. Total time of flight. Total time of flight. Total time of flight of the projectile thrown from the ground. Total time of flight in which the projectile will be in the air before striking the ground. Thrown from the ground. Thrown from the ground. This is additional information. So, and also you can draw the Parabolic trajectory described by the projectile thrown from the ground. This is the horizontal direction, and this is parabolic trajectory of the projectile. A is the highest point. We can draw a normal from the point A. At the point A, the projectile has the tangential velocity. A is the highest point, and we can draw a normal A. And H max is the maximum height attained by the projectile at the point A. The projectile was thrown from the point O with an initial velocity u at initial time t equal to 0 second, and the projectile reaches to the point A, that is at the highest point. The value of time t will be t1, that means time of descent. And at the point B, the projectile strikes the ground with the final velocity v prime, and that in time t2. This is x-axis means horizontal direction. At v, t equal t1 plus t2. Capital T1 is time of ascent, t2 is capital T2 is time of descent. So time taken by the projectile to travel from A to B is t2, capital T2, which is time of descent. So this is what the time t1, time of ascent, in which the body travels from O to A along OA, and the projectile moves downwards from A to B in time t2. T2 is the time of descent. And N is the midpoint of O and B because T1 equal to T2. N is the midpoint of O and B because T1 is equal to T2. And this horizontal displacement of the projectile is R, which is horizontal range, and from O to N is R by 2, and from N to B it is also R by 2. And R is the horizontal range. Horizontal range.